5 o'clock. Perfect time to make a video. I want to share a presentation with you by Dr. Barry Grooves. It is called Humans Carnivores. You can find it on YouTube. There is a link down below. Now the presentation is 1 hour long. I will show you some footage of it. When you have time, take a look at it. It is very interesting. Dr. Grooves explains scientifically the differences between herbivores and carnivores. What do you think human beings are? We'll find out.
On this slide I've got 6 different mammals. We've got cattle and sheep to the left in the middle. They eat grass and veggies and things that grow in meadows. Below the cattle we've got a gorilla, which also only eats leaves from about 200 different varieties of plant. Next to the gorilla we've got lions, which eat normally warm-blooded animals, antelopes, zebras and so on, which we know have saturated fat in them, and the polar bear eats seals, which of course are very fatty, and the Maasai warrior above the seal lives in his natural state on the blood and milk of his cattle. And the milk is a very high fat milk, about 8% fat, as opposed to our 3 to 4% fat. So which of these animals do you think eats a high fat diet, is designed to eat a high fat diet? Well, I want to look first of all at the gorilla's diet. From every kilogram that a gorilla eats, about 90% of it is water. Gorillas don't need to drink. They get all the water they need from the leaves that they eat. That leaves 10% or 100 grams of dry matter, of which on average 11.8 grams is protein, 7.7 grams available carbohydrates, by which I mean starches and sugars, and half a gram of fat. And that translates to 81.5 calories, which isn't very much from a kilogram of food. And it also breaks down to 58% protein, 37% carbohydrate, and only 5% fats in calorie terms. So yeah, it looks like a low-fat diet. But it isn't actually quite as simple as that. You see, about 74% of the dry matter on average in the gorilla's diet is vegetable fibre. And the gorilla is what's known as a hindgut digester. Now, hindgut digesters digest and absorb proteins, the available carbs and fats, just as humans do through the stomach and the small intestine. The undigested vegetable fibre in their diet then passes to the cecum and colon, or large intestine, which house huge colonies of bacteria. And it's here that the fibre is fermented to produce short-chain fatty acids, which are then absorbed into the body to be used as energy. And they do that at a rate of about 2 kilocalories per gram of fibre. And this changes the whole picture. If we refer back to the energy figures from a couple of slides ago, we must now add the short-chain fatty acids, 148 kilocalories, and these almost treble the total energy which the gorilla gets from its diet, which makes it look a bit more sustainable. But it does more than that. It alters the whole macronutrient profile.
So, as you can see, even herbivores, in this example the gorilla, is able to draw a huge amount of fat, saturated fat, from leaves. He has an organ for it. We do not. It gets even more interesting with cows. Now, I won't show it to you because the video would get too long, but you can watch for yourself. I really recommend it. Cows are basically a chemistry factory. As you saw with the gorilla, 13% of his diet were carbs. The cow can completely transform the plant they eat into fat and protein. 0% carbs. Let's compare human beings to gorillas.
So, have we got a large gut? Well, no. Quite the reverse, in fact. Using Kleiber's law, we find that our gut is actually much smaller than would be expected in an animal of our size. Our stomach, for example, is only about a third as big as would be expected, Our small intestine is only 3/4, and that's where most of the food is absorbed. Our cecum is practically non-existent. You can see it there. We call it an appendix, about the size of a little finger. And our colon is only just over half what would be expected. Now, all of these values are considerably less than 1. Now, this is particularly obvious in the case of the cecum. The cecum is part of the gut between the small and large intestines, which is present in all mammals, but with differing sizes depending on the mammal's natural food supply. Hindgut digesters, like the gorilla, have a large cecum, hosting billions of bacteria which break down plant materials such as cellulose. Exclusive carnivores, whose diets contain little or no plant material, have a much smaller cecum, often partially or wholly replaced by the vermiform, as it's called, appendix. And this is the case in humans. This is quite obvious when we compare the gorilla with the man in the picture I've got there. Look at the size of the gorilla's abdomen compared with a man's. This is because the gorilla's large abdomen is mostly cecum and colon, which in humans is very small. As a consequence, we absorb very little nutrition from our colons.
So as you can see, Dr. Groove explains the difference between herbivore primate and the carnivore primate. The size of organs in a herbivore is much bigger than in carnivores. Carnivores are able to be more efficient. They're lighter. They need to be able to hunt down herbivores. And they have a tiny cecum. Let's take a look now on prehistoric primates, our ancestors, and brain growth, and what gave us the edge over other primates.
But I think the most important evidence of all comes from studies of our brains. I've called it, if you want to get ahead, get a brain, because our brains are truly enormous. But they weren't always that big. Measuring cranial cavities of hominid fossils, we found that in those between about 6 million years ago and 2.5 million years ago, brain sizes remained fairly constant for that 3.5 million years. Then began a spectacular increase in size when our brains increased to 4 times the size, from about 350 millilitres to over 1500 millilitres. So we have another question. Why? What happened about 2.5 million years ago which could have had such a dramatic effect? Well, several people have come up with different answers. The answer, I think, lies in the subject which is very topical today, climate change. About 2.5 million years ago, the world cooled down and a series of ice ages began which lasted until only a few thousand years ago. For that 2.5 million years, even places close to the equator would have had a climate similar to that of Greenland today. With long cold winters and short cool summers, there would have been very few plant foods available for much of the year that our ancestors could have eaten. It was inevitable that animal food should occupy an increasingly prominent place in our ancestors' menus. Animals such as the reindeer of today have the ability to nuzzle underneath the snow to find and eat mosses and lichens which are found there. We can't eat them, of course, but they can. It was the same then. Just as the Sami do today, there is very little doubt that our ancestors must have relied on those animals for their food. They would have followed animals like the reindeer around and eaten the animals who were eating the mosses and so on.
I will show you a picture from this book. The bottom side of this diagram shows ice ages. The top side shows warmer periods. Right now we are in a warmer period. As you can see, the majority of the recent past time have been mostly ice ages. The Neolithic revolution happened approximately 10,000 years ago, after the last heat spike of the Ice Age, which enabled us to found cities and religions. So as you can see, we've evolved our brains during ice ages. It is very unlikely that there was a large plant consumption during these ice ages. We have no organ to digest fiber. Unlike the gorilla, we cannot win energy from fiber. So is there any doubt that human primates are carnivores?